Hello, welcome back to another lesson. In this lesson, we'll be considering server-side request forgery, which is SSRF. And this means that we're going to be looking at the vulnerability that turns your own server into the attacker. Server-side request forgery or SSRF is dangerous because it abuses internal trust. Let's learn more about this. So let's go right into it. Why is SSRF extremely dangerous? It is dangerous because it is not just a web bug. It exploits trust inside the network, and not just that, it bypasses traditional perimeter defenses, it targets internal systems that are not publicly exposed, and it is especially common and impactful in cloud environments. And in summary, what SSRF does is that when your server is trusted, it turns that trust into a weapon. So what is SSRF? SSRF is a web application vulnerability. So it is a vulnerability where an attacker tricks the server into making HTTP requests, and then the server sends requests on the attacker's behalf. And those requests can target internal or external resources. And while doing this, the attacker never directly accesses the internal system. It is the server that does everything for the attacker. Let's now consider how SSRF works at a high level. The pattern is simple but powerful. So it starts with an application accepting a URL as input, then the server fetches that URL, then after that the attacker manipulates the input, and then the server sends a request to an unintended internal destination. And all of this will lead to the server becoming a proxy for the attacker. Here is a simple example. Imagine an application that fetches images from a provided URL. And then we have an attacker that supplies an internal server address instead, or maybe an internal server URL. So instead of the application properly validating things or verifying things, it then blindly fetches it. That is, the server retrieves sensitive internal data. And after that, the attacker receives the response. In all of this, no firewall was bypassed directly. It was the server that did the work. Why is SSRF so powerful? It is very powerful because internal systems trust internal traffic. That means server is trusted inside the network. And another reason is that server can access internal IP addresses. It can reach services that are not exposed to the public internet. Also, it can communicate with databases and internal APIs, and all of this makes it so difficult to detect. And this means that detection is difficult because the request originated from a trusted host. Now let's consider SSRF in cloud environments. Cloud makes SSRF even more dangerous. How? Attackers can target cloud metadata endpoints, and these endpoints can return temporary credentials. That is, they can steal temporary credentials through that, and stolen credentials can lead to privilege escalation. Also, many major cloud breaches have involved this pattern. That is, it is a major cloud breach vector. Now, what can attackers do with SSRF? The impact of SSRF can escalate quickly, and here are what attackers can do with it. The first one is that they can access internal services with it. The second one, they can scan internal network ranges. The third one, they can retrieve sensitive files or configuration data. And lastly, they can steal cloud credentials and tokens. And this means that SSRF can move an attacker from just having a web access to compromising the full infrastructure. Next, let's consider the common causes of SSRF. SSRF often results from poor validation. So let's consider some of the common causes of it. The first one is unsanitized URL input. That is, if URL inputs are being passed to the server the same way they are being given to the web application or to the system. Another one is blind trust in user-provided URLs. Then the next one is lack of outbound network restrictions. When there are no restrictions for outbound network, then SSRF is not far from that organization. Then SSRF is not far from servers or systems within that network. Also, when we are not filtering internal IP ranges. Filtering internal IP ranges is something every cybersecurity professionals must ensure as well. And I must add that small validation mistakes can create large attack paths. So developers need to validate, verify, and sanitize all inputs before being processed. Next, let's consider blind SSRF. Sometimes the attacker does not see the response. And what they are doing at that point is called blind SSRF. So for blind SSRF, the server still makes the malicious request and the attacker confirms success through some side effects, for example, DNS callbacks or timing differences, and this makes detection and investigation harder. How can we prevent SSRF? Defending against SSRF requires strict controls, and here are how we can prevent against it. So the first one is that we must validate and whitelist allowed URLs. So if we have URLs that are unallowed, then we should blacklist them, or they shouldn't be whitelisted at all. The next thing is that we should block requests to internal IP ranges. Next, we should restrict outbound network traffic. Next, we should enable metadata protection mechanisms in cloud environments. And all of these are very important because prevention must be both application level and network level. Now, let's consider network level protections. Infrastructure matters, and that is why we need to protect our network. And to protect our network, we must apply firewall rules for outbound filtering. We must segment internal services. We must disable unnecessary protocols. And we must enforce least privilege on services and instances. And all of this will help us because even if the application fails, the network can limit the damage. Next, let's consider SSRF and the CIA triad. SSRF affects all the three core security pillars. Confidentiality can be breached through unauthorized internal access. Integrity can be compromised through internal service manipulation. Availability may be affected through abuse of internal systems. And SSRF can impact all the three. Some people see this to be a minor vulnerability, but this minor vulnerability can impact all the three core pillars of cybersecurity. Now, we should ask ourselves, why is SSRF increasing? It is increasing because modern architecture increases exposure. We now have cloud adoption growth, that is rapid cloud adoption happening across many organizations. Also, we now have microservices systems that are communicating internally. We now have API-driven systems everywhere. And we also have complex internal network designs. And the more internal connectivity exists, the higher the likelihood and the impact of SSRF. What have we learned so far in this lesson? We've learned that SSRF abuses server-level trust. We have seen that internal systems are high-value targets. We've seen that cloud environments amplify impact. We've also seen that proper input validation and strict network controls can significantly reduce the risk of SSRF. And the summary of what we've learned so far is that we should never assume internal means safe. The fact that it is an internal network does not mean that it is safe. Let's take a test together. Here is the question. What makes SSRF especially dangerous in cloud environments? Here are the options. Pause your video, read through the options, drop your answer in the comments, then come back to play the video. What is the correct answer? B, which is it allows attackers to access cloud metadata services. That's all for this lesson. Please do not forget to like, share, and comment. And if you're yet to subscribe to our channel, kindly do that now. Thank you, and see you in the next lesson.